Students are not showing the interest on the studies particularly. They want the degree, but they won't want the studies. This is going on, the situation. It's a worse situation after the pandemic. So anyhow, the yesterday class we discussed. Sorry, ma. Tell me. Wait, my voice is audible, na?
Yes, sir.
Okay. Why? Because what I am observing is last few years onwards, before that, in my study center, at least 250 to 60 members for the chemistry. If you go to the science and technology, minimum 150 members will be present in my class. But today, online, throughout the state, not only the state, both the states, Andhra Pradesh and Telangana, just we are attended the 7 members only. I think about it is not online class. Okay. Better next time onwards, I can move aside. Okay, fine. Right. Whatever it may be. Now coming to the last time, that is yesterday we were discussing about the groups for third and fourth groups. Today we are discussing about the fifth A group elements. So what are the fifth A group elements? You are see that one. The fifth A group elements are nitrogen, phosphorus, arsenic, antimony, and bismuth. You know, the nitrogen is the 7th element in the periodic table. Just add 8, that is the 15. Again 18, 33, it is the 51, and 83 is the bismuth. Okay. So what I say, first we read the property is electronic configuration. So first element 1s2, 2s2, 2p3. The short form is helium 2s2, 2p3. Just keep in mind. Okay. It is the 15th element, means 1s2, 2s2, 2p6, 3s2, 3p3. It is nothing but neon 3s2, 3p3. Similar manner, we are writing of the arsenic, that is argon 4s2. Sorry, before that 4s2, you can write as a 3d. Every time remember, if you are getting the 4th orbital s orbital mix, before 3d will be there. 3d10, 4s2, 4p3. Similarly, antimony, krypton, 4d10, 5s2, and 5p3. Now coming to the bismuth, it is a xenon. Now 6 is 6s2, 6th orbital of s orbital is in 6th orbital. S orbital is coming, means definitely f orbital is present. So 4f40, 5d10, 6s2, and 6p3. This is about regarding of the electronic configuration. Okay. So this is the 5th group elements electronic configuration. The general electronic configuration of the 5th A group element, general electronic configuration is ns2 np3, because the last electrons which are present in this is this particular electronic configuration is this one, and this belongs to p block elements. Okay. So general electronic configuration is ns2 np3, and it belongs to the p block elements. And you know that the common oxidation state, if you say that one, this is the particularly nitrogen. If you see the p orbitals in the nitrogen, it is off-filled orbital. The p orbital, that means 2p is consisting of px, py, pz. It is outfield orbital. This outfield orbital is very stable than the incompletely filled orbital. So nitrogen does not lose the electron from the p orbitals. Please remember, only these 2 electrons will be removed out. That's why the oxidation state is +2 only, not the +5. The valency is nothing but the valency is a +3. Again, valency is the 3, valency is there. So that's why we are getting of the ammonia NH3. Valency means what? Combining capacity. How many number of elements are combined to the central atom? That is called as a valency. Here the valency will be the +3 one. Okay, now this is nothing but the group number. Here you are having of the 8 minus 5. 8 by group, that is valency is nothing but 8 minus group number. Group number is the 5th one. So 8 minus 5 is 3 is the valency is there. So this is about this one. Now coming to the particularly this particular nitrogen. If you are seeing of this one, already you know that one, the general electronic configuration and p block elements, and you are having of the specific case of the nitrogen. This nitrogen is a diatomic nature. Nitrogen is atomic nature. But if you see phosphorus, arsenic, antimony, and also you can say the bismuth. These are the bismuth is a why, because after the 82 lead, after the 82 lead is bismuth. It is a radioactive nature. Lead is non-radioactive element. Bismuth from the bismuth onwards radioactive nature. These three, it is in tetraatomic state. There are tetraatomic state will be appears. It is a diatomic. Diatomic means this nitrogen is consisting of a triple bond between the nitrogen and nitrogen. This is a diatomic. So you are writing the nitrogen molecule. But here you are writing the molecule is phosphorus P4, arsenic AS4, antimony. This will be happened. How the structure will be? See the structure of the, if you are taking the phosphorus, okay, the bond is like this. This is the bond will be appears. This is the phosphorus P4 structure. Okay, so we are getting off the arsenic same, and then the steel bond is also same. You are getting off. This is about the regarding of the general information of the 58 group elements. Okay, coming to the hydrides. Now already you are discussing after the electronic configuration property. You can discuss it about the hydrides. Hydrides are you are using of the same, just like the we are discussed it last time. That is the carbon hydrides. That is the hydrides of the 4th group elements. Here also the hydrides are similar manner. Ammonia means it is a nitrogen is the valence is a 3. That's why 3 hydrogens are attached to this one. These are getting of ammonia. Hydrides are ammonia. Next is phosphine. Please remember phosphine. PH3 is called as a phosphine. Arsine. ASH3 is called as arsine. Stilbene. That means this is antimony. This is a name is the antimony name is stilbene. That is you are getting of the stilbene and also bismuthine. These are the types of hydrides are possible for this particularly. So in this case, ammonia, you are having of this ammonia is a not a tetrahedral structure, trigonal planar structure, but undergoing of sp3 hybridization. The bond angle of ammonia is 107 degrees 48 minutes. Due to of this particularly reason of ammonia is getting received, this is hydrides. So that means when the hydrogen is added to this particular 58 group elements, you can form the different type of hydrides, the same type of hydrides, ammonia, phosphine, arsine, like that we are getting. So next coming to the property of oxides. These 58 group elements can form trioxides as well as pentoxides. 2 types of oxides are possible. Tri and pentoxides are present. Okay. So trioxides means nitrogen can form trioxides, phosphorus, arsenic, antimony, bismuth. Here among all the trioxides we are getting up. Pentoxides also all the elements except bismuth can form the pentoxide. Why? Because bismuth is having of the inert fair effect is there. That is the 4F black elements are entering that one. Bismuth does not form the pentoxide, but remaining other elements can form trioxides as well as the pentoxides. Okay, trioxides as well as the pentoxide. This is N2O3. We're going to P2O3 pass point. This is the nitrogen trioxide that will be formed. Special case of nitrogen. Nitrogen can form different types of oxides. That is a different types of oxides are. We can use it as NOx type. This is a type of oxides are which are possible. So why it is happening? See, means because nitrogen is abundant, is present in the atmosphere. Our atmosphere gas is consisting of so many number of gases are there. In that, nitrogen is most amount, that means abundant gas. That is 78% of the nitrogen is present in the atmosphere. That 78% of the nitrogen during the thunderstorms in the rainy season, it will be split into number of ions, formation of different oxides. The oxides of the nitrogens are, you can write as nitric oxide, NO, nitrous oxide, N2O. Okay, see friends, remember this particularly oxides of the nitrogen is nitrous oxide, nitric oxide. I'm using of nitrogen trioxide, N2O3, nitrogen dioxide, there is nitrogen tetroxide, and nitrogen pentoxide. These are the possible oxides of the nitrogen. Nitrous oxide, nitric oxide. Okay, please remember the nitrous oxide means NO. Nitric oxide, nitrogen trioxide, nitrogen tetroxide. This is nothing but nitrogen dioxide only, NO2. Okay, nitrogen pentoxide. This is a possible of whatever the actually oxides are, the 58 group elements can form tri and penta. But nitrogen special case, they can form not only the tri and penta, mono, di, tri, tetra, penta also form. This is a possible. Why? Because the nitrogen is plenty of the nitrogens are present in the atmosphere during the thunderstorms in the rainy season. So the nitrogen molecule split into the ion, formation of different types of oxides. These oxides are dissolved in the rainwater, formation of acid rains. That means we are getting of the whatever the sulfuric acid or nitric acid. These nitric acids are present in the rainwater. We are getting of the acid rain. Now coming to this oxide. Particularly, first I am taking the nitrous oxide, NO, nitrous. This is called as a nitric oxide. In your examination, there is a chance of asking of this nitric acid. What do you mean by the nitric acid? Is called as a laughing gas. Because when you release the nitric oxide more amount in the laboratory, you can laugh. This, it will be leads to the hysteria also. The patients, mentally retarded patients will be laugh every time again and again because of there is a consisting of the more amount of nitric acid is present in their body. That's due to that reason only we're getting off laugh. That's why N2O is called as a laughing gas. Please remember this is in the examination maybe asking of that one. This is the oxides of the nitrogen. Okay. So friends, here already we are familiar of this about the nitrogen and phosphorus. Every group we are discussing about these are two. Now I am discussing about the oxides of the nitrogen and also oxyacids of the nitrogen. The 5 marks question. This is a 5 marks question. This is a 5 marks question. And also you are writing the pentoxide. Bismuth does not form the pentoxide. Only remaining other can form because of inert pair effect. Inert pair effect means it is a 4 orbitals are entered. It is act as a shield or it is nothing but sheet of that one. So that one it is called as an inert pair effect. Due to that one, it can act as this one. Okay. So this is about the oxides. Now we are discussing about the oxyacids of the nitrogen. What are the oxyacids of the nitrogen? See, for the examination point of view, it is a 5 marks question. Oxyacids of nitrogen. Very simple to remember, only 4 are there, the oxyacids. That is particularly easily to remember that one. You can, idea, clue is there. First oxyacid is called as hyponitrous acid. And I think this one particularly hyponitrous acid. Second one. Then after I can write the formula. After the hyponitrous acid, you write nitrous acid. See what happened in the examination point of view for remembering purpose. First remember the hypo. Just remove the hypo. You are getting of nitrous. Third one, nitric acid. Already you are familiar with this particular formula, nitric acid. Next, last one in this oxy acid of the nitrogen, pernitric acid. Just remember these are the words which are using of that one. Next, you can write the formulas. This one. Hyponitrous acid, the formula is H2N2O2, nothing but HNO. It's a dimeric form. Okay. So H2N2O2 is the hyponitrous acid. Next is nitrous acid. Just you are using of HNO2 is called as nitrous acid. Already you are familiar with the nitric acid. What is the nitric acid formula? HNO3. What is pernitric acid? It is nothing but HNO4. See, easy to remember the oxy acids of the nitrogen. This 5 mass bit. First HNO, HNO2, HNO3, HNO4. First HN. Why? Because HN I am using it is a dimeric form. Dimeric form. If I write the monomeric form means HNO is also correct. HNO. This is nothing but H2N2O2. HNO2. That means oxygen is increases. Oxygen is increases. That's why hyponitrous acid, nitrous acid, nitric acid, and pernitric acid. Okay. Already I wrote the oxides of the nitrogen. Nitrous acid is NO. Nitric N2O. N2O is called as a laughing gas. Nitrogen trioxide N2O3. Nitrogen tetroxide N2O4. Nitrogen pentoxide N2O5. Similar manner, the oxy acids of the nitrogen means you are dissolving that one oxides of the nitrogen in the water. So you are getting of the nitrous acid. That is a hyponitrous acid HNO2. Sorry, H2N2O2. Nitrous acid means HNO2. Nitric acid HNO. Now this, if suppose you are after the writing of the formula, what is the structural formula? If you are writing of the structural formula also very easy. Why? Because already 2 nitrogens are there. It is a 2 nitrogen means already I showed that it is a dimeric form. It is consisting of a double bond is present between that one and OH group is side along that one. We are getting off this one and triple bond also present and each nitrogen atom. This is a structure. Structure of hyponitrous acid. Structure of hyponitrous acid is, this is the easily to remember this one particularly. Okay. Next one is this particular, easily write 1 HO and 1 double bond O. This is a nitrous acid. So next one is nitric acid. The same formula I am repeating. Just see how I am writing this one. A oxygen O minus which is present and the single bond O minus. This is called as a nitric acid. Okay. Pernitric acid means peroxide type is there. Pernitric acid means HOON double bond O and O single bond minus. What do you do here? See, this is a dimeric form. That's why you are getting off this one. In between the double bond is there. OH group is there. Here OH is there. One is the double bond that between the nitrogen and oxygen. Same or nitrogen oxygen we will, but one more oxygen. It is a vacant. One means it is a negative. Means more electrons will be present on the oxygen. It will be bonded to the other atom. Per means O. Oxygen. Pernitric acid. This is a nitric acid, but HO. This is a pernitric acid. Again, this is a bonded with. This is about the oxy acids of the nitrogen. Okay. So please remember, nitrogen is having of oxides as well as the oxy acid. Now coming to the very important. This is a 5 marks question. Very important. Next one is the preparation of nitric acid. Preparation of nitric acid. It is a very, very important 10 marks question. Preparation of nitric acid. I will give just a few steps in this nitric acid preparation in the process of Ostwald process. So, preparation of nitric acid by, we are having of the one major important is Ostwald's process. This process is there, Ostwald process. In this, we are preparing the nitric acid. So what you are taking what are the raw materials in this means Ostwald process? We are taking as ammonia and oxygen. It is in 1:8 ratio. that you are taken as the raw materials in the osmotic process, preparation of the nitric acid, ammonia and oxygen is taken. Oxygen means you are not taken. Just in the plants, we are getting off the directly oxygen with the help of the atmosphere. So your ammonia is a major important. That is a one part only. Remaining parts are 8 parts. What you take first, you have to take in the catalyst chambers are there. In the asphalt process, we are having of 3 chambers. One is a catalytic chamber. One is that is a dissolve. That means you are using of the cooling chamber is there. Next, we are getting of that one. So the 3 towers, one is a catalyst chamber, next is a cooling chamber, next is the, you are having of the next chamber is the absorption chamber. Absorption means water molecules will be absorbed in that way. So these are the 3 chambers which are present in the asphalt process. First, you have to take the ammonia and oxygen, the atmospheric oxygen present in the catalytic chamber. Catalytic chamber means you are taking as like this, the equation. When the ammonia is oxidized in presence of platinum gas. That means it is a catalyst. The catalyst chamber, it is a platinum wire will be there. The gas is there. Mesh is there. In that, we are passed the ammonia and the oxygen. That will be passed. That one we are getting off nitrous acid. This nitrous acid is evolved. This nitrous acid is again the second step. This is a first chamber. Second chamber. It is a cooling chamber. Again, it will be cooled. That means in the presence of oxygen only. In the cooling chamber, formation of nitrogen dioxide. So very simple in the asphalt process preparation of the nitric acid is first in the catalytic chamber, you have to pass the ammonia gas. This simply nitric acid is formed. The nitric acid again in the cooling chamber. Cooling chamber oxygen is present. So then the cooling chamber nitric acid is reacted with the oxygen formation of nitrogen dioxide. In the third chamber, that is the absorption chamber. So nitrogen dioxide is, we are using of the hydrolyzed in the absorption chamber, formation of HNO3. Nitric acid is formed. But in this third chamber, whatever the nitric acid is obtained, it is almost all 68% of the concentration of the nitric acid only. Only 68% will be present. This particular 65, I want to 100% means what you do? Again, it is treated with the sulfuric acid. So why, sir, sulfuric acid is required? The sulfuric acid is very important dehydrating agent. Dehydrating agent means it removes the water molecule. So in this water molecule, 32% of the water molecule is present, so that will be reacted with the water molecule. So immediately remove the water molecule, getting off 100% of the nitric acid. This is the process of asphalt process. It is a 10 marks question. Write the simple theory. In this asphalt process, we are taken as the raw materials of ammonia and oxygen in 1:8 ratio. First, you have to take it as a catalytic chamber. Catalytic chamber consisting of the platinum gas. There is a mesh is there. When the ammonia is passed through the platinum gas, it will be reacted with the oxygen. That means partial amount of the oxygen is reacted with and you are getting off nitric acid. This nitric acid is again passed into the cooling chamber. In the cooling chamber, again the oxygen is reacted, small amount of oxygen reacted, formation of nitrogen dioxide. This nitrogen dioxide, whatever the nitrogen dioxide is obtained from the cooling chamber, you can pass to the absorption chamber. Third chamber is known as absorption chamber. In this absorption chamber, water molecule is reacted with the nitrogen dioxide, formation of nitric acid. The obtained nitric acid from the absorption chamber is maximum is 68%, not more than that one. So this nitric acid is only 68%. To get the 100% of nitric acid means you can treat this particular nitric acid with the sulfuric acid. So sulfuric acid acts as a dehydrating agent. It removes the water molecule from the nitric acid. You will get the 100% of the nitric acid. This is a process is called as asphalt process. Okay, it is a 10 marks question. Now coming to the next, we'll go to the phosphorus. What is the importance of the phosphorus? So again, you are having a phosphorus oxyacids. What are the phosphorus oxyacids? It is a 10 marks question again. So 10 marks questions are 2 nitric acid preparation and phosphorus oxy acids. The oxy acids of the phosphorus, we are having of that one. So here also, remember the name of the oxy acid and formula structure. These 3 are important. In your book, suppose if you go to your textbook, I will give the list. Why? Because the tabular formula is given in that one. It is also very easy to remember, easy one, everything. We'll tell the page number 36. Sorry, not 36.
47, sir.
47.
43, Nana.
47, sir.
47. Okay. 43 is oxy acids of the nitrogen. 47 is the oxy acids of the phosphorus. It is a 10 marks question. Here also, if you observe that one, the table, we are having of hypophosphorus acid. First, we also taken in the nitric acid, oxy acids. Also second, hyponitrous acid, nitrous acid, nitric acid, pernitric acid. Similar manner here, hypophosphorus acid. Next is phosphorus acid. Next is hypophosphoric acid, orthophosphoric acid, pyrophosphoric acid, metaphosphoric acid. 6 are there oxy acids of the phosphorus. You have to remember the 6 oxy acids and with the formula. So hypophosphorus acid is H3PO2. Hypophosphorus acid is H3PO2. Phosphorus acid is already I told it H3PO3 is called as a phosphoric acid or phosphorus acid. Phosphoric acid also same that one H3PO3. Okay. So hypophosphoric acid H4P2O6. Hypophosphoric acid H4P2O6. Then orthophosphoric acid, it is nothing but H3PO4. Orthophosphoric acid. Next, pyrophosphoric acid, H4P2O7 is called as pyrophosphoric acid. And metaphosphoric acid, the simplest form of the phosphoric acid is metaphosphoric acid is HPO3. HPO3 is called as a metaphosphoric acid. Shall I write on the board? No need, na? Just go through 47 page number. That is whatever the formulas is given. Not only for the 10 marks question, this particular tabular form you can also present. That means you can appear in the multiple choice question. They will ask the particular formula. What is hypophosphoric acid? Formula is. Sometimes mostly I ask that the pyrophosphoric acid. There is a pyrophosphoric acid is H4P2O7. Or metaphosphoric acid, HPO3, metaphosphoric acid, or phosphorus acid, H3PO3. This is also phosphorus acid also. Sometimes the pronouncing as phosphoric acid also. Both are same. Phosphorus acid or phosphoric acid is also same. The formula is H3PO3. So in the multiple choice questions also, they will ask about the formula with the name. Remember this, but 6 names are there, 6 formulas are there, and 6 structures are there. No need about remaining other, whatever the in the table is given, the oxidation state or whatever that one properties. We don't want that one. Okay, only we require 3 columns only: name, formula, structure. This is enough for the 10 marks question. Okay, so I don't want to waste my time to write off all the things in the board. Okay. Next, we will go to the simple manner. There is a very important questions regarding on this particular phosphorus. You are having of the superphosphate. It is a repeated question in the examination. How to prepare superphosphate? Actually, that is also present in our first sem also. Superphosphate offline. Here only you are asking about the what is superphosphate. So the preparation of the superphosphate, you can asking of this one. I can write this is a superphosphate. The formula is calcium hydrogen phosphate H2PO4 taken twice plus 2 calcium sulfate. Remember friends, this is a particularly calcium hydrogen phosphate CaH2PO4 taken twice plus 2 calcium sulfate is called as superphosphate. It is a fill in the blanks question compulsory. What I am using stressing of the word, please remember this. If you are go through the any previous question paper, if you see that without this question, won't getting of any question paper. That means that much of importance is given by superphosphate. Why? Because it is a used as a fertilizer for the farmers. So how to prepare? Already in the first time I told that the superphosphate of lime, same process here also. What is the superphosphate of lime? Means here also superphosphate is prepared by means of the raw materials are required of two only, rock phosphate and sulfuric acid. What is the formula of rock phosphate? Again, you have to remember Ca3PO4. Okay, rock phosphate is Ca3PO4 taken twice is called as a rock phosphate. This is also called as a bone ash. I heard about that. Just you remember your previous classes, in the first time classes. I explained clearly regarding our superphosphate of lime preparation. Same, that is only here also. Superphosphate, the rock phosphate, or calcium phosphate, or bone ash. The three names are there for this formula. What is that? Ca3PO4 calcium phosphate. Where it is available, Amma? Anybody? Do you have the calcium phosphate in your body? Okay. Which is a strong strong organ. You can't say the organ. Teeth. Our teeth is there. The teeth is consisting of calcium phosphate. This is the strongest enamel which is present on our particular teeth. The teeth is our human being teeth. Nothing but the calcium phosphate. It is called as a rock phosphate. It's called as a bone ash. Our bones is consisting of the calcium phosphate. Okay. Everywhere. Without calcium, you can't. That's why every human being requiring of minimum amount of calcium. Minimum how much? 1 kg of calcium is required for the human being to sustain the life. So essentially the calcium is there for strengthening of your bones, teeth, and everything. That's why particularly female required more amount of the calcium than the males. Every day you can drink 1 milk, that means 1 cup of milk, or egg, that is a white. You can getting of the rich amount of the calcium. So the calcium phosphate, it is called as a rock phosphate. It is also called as a bone ash. First, you have to crush into the fine powder. The calcium phosphate or rock phosphate, make into the fine powder. And this fine powder is taken as a one major tank. There is a big tank and it is dipped into the concentrated sulfuric acid. That means it is dissolved in the concentrated sulfuric acid and kept aside in the black, that means in the dark room for about 48 hours. So dark room, about 48 means, that means it is nothing but process is called as a fermentation. So the rock phosphate is dissolved in the sulfuric acid. During the 48 hours, it is fermented. That means fermentation takes place. Formation of, what do you get? Superphosphate. That is CaH2PO4 taken twice plus 2 calcium sulfate. It is nothing but the gypsum remaining. The strengthening of that one. It is called as a superphosphate. This is a preparation, very simple preparation. What is the use of the superphosphate means? The major use is it is a good fertilizer. For the farmers, it is getting of the good yield of the any paddy or sugarcane, you are getting of the good yield by using of this superphosphate. Okay, this is about the main important of the superphosphate. Next, 2 more important preparations are there that I will explain very little bit short of that one. That is hydrazine and hydrozoic acid. They also are asking about the hydrazine. So next, hydrazine preparation. First of all, what do you mean by the hydrazine? What do you mean by the hydrozoic acid? That is also, remember, N2H4 is called as hydrazine. Remember the formula. Just for inorganic chemist, formulas are very important. Inorganic chemistry, we have multiple choices so many times. What is the hydrazine formula? Means N2H4. What is hydrozoic acid? Hydrozoic acid means NH3 is ammonia. N3H is called as hydrozoic acid. See how the difference is there. So don't confuse of remembering of the formulas. Here, first of all, we can discuss about the hydrazine. This hydrazine, this means N2H4 is called a hydrogen. How to prepare this hydrogen means simply we are getting of the ammonia and sodium hypochlorite is passing into the electric discharge to ammonia and sodium hypochlorite. Ammonia and sodium hypochlorite is passed through the electric discharge. Ammonia, I'm writing, and sodium hypochlorite, NaOCl. Sodium hypochlorite, and passed this one, you are getting off N2H4 and sodium chloride, and also liberation of small amount of the that is HCl also liberated out. This will be formation will be byproducts which will be present of this byproduct. Our important is the hydrazine. Hydrazine preparation is, this is a simple, if it's the 5 marks question also, just first write the formula of hydrazine, that is, and the preparation is when the ammonia is, there is a boiling state of the ammonia, actually is a heat, fumes are getting off, it passes through the sodium hypochlorite, NaOCl, you pass it through that one, you are getting off the hydrazine. This hydrazine structure, if you see that one, why? Because only one preparation is there. What are the remaining others means we don't have that much important of this particular hydrogen. Just write the structure. The structure of the hydrogen is, this is a structure. That's enough. In between the nitrogen and nitrogen, there is a no double bond is present. Please remember, before that one, ammonia, nitrogen is having a triple bond is there. But here in the hydrogen molecule, we are having of a single covalent bonds only. All are just like the ethane structure. Just like ethane structure is formed. This is called as hydrazine. Next important is hydrozoic acid. Hydrozoic acid. It is also very important in your examination purpose. So, please remember the formula of hydrozoic acid, N3H. You are writing out the ammonia is NH3. See the difference. Ammonia formula is NH3. Reverse order means N3H is called as hydrozoic acid. N3H is called as hydrozoic acid. The remember formula of that one, hydrozoic acid. Now the hydrozoic acid is prepared by means of the sodium amide. The sodium amide is passed to the nitrous acid. You are getting off hydrozoic acid. Sodium amide. What is the sodium amide means? Sodium amide means NH2. When sodium amide is treated with the nitrous acid. Nitrous acid, what is the nitrous acid? It is a laughing gas. Nitrous acid N2O. You will getting off hydrozoic acid. If you want this one, you can write as like this. Okay. So sodium amide. This is called as a sodium amide. It is sodium hypochlorite. Sodium hypochlorite. It is. So the difference between this one, you are getting off the, don't confuse here. Sodium amide, which is reacted with the nitric. There is a particularly your formation of the nitrous acid. Nitrous acid, you are getting off. This is the nitrous formation of hydrozoic acid. So hydrozoic acid, if you want the formula also, there is a structural formula. If you're writing off that one, I can write off tau. Because almost it is a over of this chapter. The hydrozoic acid structure is N3H. The bond is like that. It is bent like this. The structure of N3H hydrozoic acid structure. Okay. So this is about the fifth, that means 50A group elements in the block 1, third lesson. We'll go to the block 2. Block 2 is organic chemistry. In this organic chemistry, your unit is 4 is alkynes. Now we are discussing about this alkynes. What are the alkynes? Alkynes means what? Alkynes are nothing but it is a very unsaturated hydrocarbons are called as alkynes. Very, very unsaturated hydrocarbons. Alkynes are unsaturated hydrocarbons. Unsaturated hydrocarbons. Consisting of a double bond between the carbon and carbon. It is called as alkynes. Ine is called as a triple bond is present. This is called as ine. And general formula of alkynes is CnH2n minus 2. This is very important. The general formula of alkynes is CnH2n minus 2. See, in this particular case, this particular alkynes can undergo isomerism. Particular type of isomerism is only functional isomerism. Not we are having of isomers are chain isomerism. Okay, functional isomerism. And also one more. Anybody knowing of the first SEM?
Position isomerism.
Sorry?
Position isomerism.
Yes. Position means only position will be changes. Here, I'm using the positional isomerism. Functional group changes is called as a functional isomerism. Position of the element or the whatever the group will be changes the positional. Here, particularly alkynes can undergo only functional isomerism, not the positional isomerism. Why? Because it consists of triple bond. But if you see the alkenes, the position will be changes. 1-butene, 2-butene. Means 1-butene means double bond will be changes to first position and it will go to the second position. That's called as a positional isomerism. The functional means functional group itself is changing. So alkynes can undergo functional isomerism. Now see this particular alkynes. In this particular alkyne is the best example of the alkyne. The first member is CH2. I'm writing this is C2H2 is called as ethine. Ethine. Or you can say it is called as acetylene. The common name is acetylene. Okay. Garlic smell is getting off this one, acetylene. Now this ethyne molecule, this triple bond means it can undergo the hybridation is sp3 sp hybridation, and the structure is linear and making of the bond angle is 180 degrees. A linear structure is there. It is a straight structure, a linear structure, and making of the bond angle is 180 degrees centigrade. And between the triple bond, you know that one, single bond, carbon-carbon single bond length is 1.45, that is 1.54 angstroms. If the carbon-carbon double bond, the length, okay, this is 1.34 angstroms. Coming to the carbon-carbon triple bond, this bond length is 1.2 angstroms. Suppose 20 also you can write 1.2 angstrom. The bond length between the carbon and carbon is 1.2. Here, if you comparison, I will given as a structure. Single bond length is 1.54, double bond length is 1.34, and triple bond length is 1.2. If you observe, this is that means the carbon-carbon very close to each other. That means it is a very, very unsaturated. That's why it is unsaturated compound which is present in that particular alkyne series. This is particularly regarding about this one. So the positional and whatever the isomerism regarding of that one we can discuss later. But the important points are it is unsaturated hydrocarbon and it is undergoing of sp hybridation. It is a linear structure. Bond angle is 180 degrees and the bond length between the carbon and carbon is 1.2 and general formula is CnH2n minus 2. That's enough for your examination point of view. Now coming to the preparation of the alkynes. The general preparations of the alkynes, in that the first member is acetylene. Okay. So for your examination point of view, it is a 10 marks question. What is the general preparation? We'll discuss the Very little bit fast. Preparation of alkynes. Here, no, nothing to confusion. Why? Because in the examination, there is nothing is there. Alkanes are there to confusing. Why? Because in the first time, so many students are. I asked the preparation, write the preparation of alkanes, but now number of students are written as alkenes preparation. You will getting off under 0 marks. Please read the question properly in the examination. Which question I am asking? You write that question answer only, not irregular. Whatever the you having of idea, don't write that one. Why? Because it is a science student means you will getting off exact marks. If you are writing wrong means you can get giving up the 0 only, not any one single mark. Please remember, keep in mind as a science students, please, it is an exact answer only. Why? Because it is not a critical matter. If you go to the political science and public administration, sociology, whatever you are writing means, they will giving up. If the correct, it is a not correct answer, they will give at least 1-2 marks. But here won't give 1-2 marks also. 0. If you're getting off the correct answer means you will get the 10 to 10. Nothing to worry. If it is not means it is a 0. Sometimes they are asking preparation of how many you can write, sir. So always we are first sem onwards. I will explaining. The question is write the preparation of alkynes and also its chemical properties. We will ask the 10 marks question. So preparation means at least you have to write to 3 preparation, minimum 3 preparation, and the minimum 3 properties. 3 chemical properties you have to write. Then only it will be suitable for the essay type question. Suppose it is a 5 marks question means just write the 2 preparations is enough, or one preparation also sometimes. One is a 5 marks question, but the 10 marks question you have to write the minimum 3 preparations and minimum 3 properties. So the preparations of the alkynes, particularly I am using of the industrial method first. For the industrial method purpose, we are preparing that one, that is means of the when calcium carbide. This yesterday I told that carbides. The calcium carbide is hydrolyzed. Formation of acetylene is prepared. This is used for the purpose of what? The vendors, fruit vendors are using of the calcium carbide. The spraying of the water. Immediately raw mango will be getting into artificial ripening of the fruit. This is acetylene is act as a artificial ripening of the fruits. Fruit that ripens. Not only that one, it is used as a gas welding, arc welding purpose. That means we are using a main important of this particular acetylene gas is used for the gas welding. Okay, cutting of the metals also. The metal will be cut with the help of this gas, acetylene gas. Welding purpose as well as a cutting purpose. This is industrial method of the preparation of the your acetylene or alkynes. Now coming to the second. Dehydrohalogenation. See the meaning of this one, dehydrohalogenation. What do you mean? Dehydrohalogenation means removing of 2 hydrogen atoms and 2 halogen atoms are you are removing. So you are removing. Just I will take as the consideration of. See, I am writing the structure. Dihaloalkanes. This is a dihalo. 2 halogens. You can keep as a chlorine or bromine, whatever you want. Okay. If it's a chlorine, I'm writing means 1,2-dichloroethane. See, I'm writing the general formula, not the common formula. If you are keeping up the chlorine instead of X here and here, that means here you are keeping the chlorine, here you are keeping the chlorine. The name of this compound is here the first position, it is the second position. 1,2-dichloroethane. It means 2 carbon atom. It is a saturated hydrocarbon. See, it is a ethane. 1,2-dichloroethane. But the common I am taking dihaloalkane. alkanes, dihaloalkanes. Dihaloalkane. I'm taking off common. If you want the example means you can take this one. Okay. This is for the example. Okay. These dihaloalkanes are treated with the alcoholic potassium hydroxide. You are treating with the alcoholic potassium hydroxide. Removing of this particularly, and it is particularly here that is removing. So formation of H. See this one, and then 2HX. Alkynes are prepared. Very simple preparation of this particular alkynes by means of dehydrohalogenation. Dehydrohalogenation, very simple for getting off that one. For that, if you want the example, I can also write here CH2Br, CH2Br. With the help of alcoholic potassium hydroxide, suppose. What is the name of this one? Please remember that. Try to give the name. Anybody? 1, 2 dibromo means ethane. This is 1, 2 dibromo ethane. So organic chemistry, all of you forgotten. It's very important, Amma. 1, 2 dibromo ethane, alcoholic potassium hydroxide. We are getting off ethylene and HBr, 2 molecules of the HBr. That means ethylene is prepared. This is about the example of this particular dehydrohalogenation. Next, we will go to the dehalogenation, simple dehalogenation. Third method, I am writing of dehalogenation. Means what happened here? Only you are removing of halogens. That's all. Here, hydrogen as well as halogens are removing. But here, only halogens are removing. That is nothing but I'm taking off the compound is very simple compound here. Suppose I'm taking of general. Can anybody say the name? What is the name? Try. Okay. Tell me, Mama. First question, 2 halogens are there. And the second question, 2 halogens are there.
1, 1, 2, 2.
Right. 1, 1 and
2,
2. So total how many?
Tetra.
Tetrahaloalkane. Okay, ma. So 1, 1, 2, 2 tetrahaloalkane. That's all. Okay. Please write practice it is one. Then only it will be easily. This tetrahaloalkanes are treated with the zinc dust. It is a reduction process. When the zinc dust it is treated, the formation of simply a triple bond alkynes. Alkynes are prepared and zinc halide. Okay. So whatever the number will be, we are getting off ZnX or ZnCH2, Cl2, we are getting off. The remaining will be formation. Okay. So this is a dehalogenation. Halogen will be removed out. We are getting off with the help of this is a zinc dust we can using of in this reduction process. This is about the preparations of the alkyne. See how it is easy. It is a 10 marks bit amount. Just remember, keep in mind of that one particularly. Why? Because you are having of the very important preparation. The main important is industrial preparation. This will, it is actually the Europe countries and foreign countries this banned the calcium carbide. Previously, our India also banned, but most of the our vendors will getting from the China market the calcium carbide. It's a very hazardous material to our life. Okay, so you are keeping of this particular ripening, artificial ripening purpose. They are using of this calcium carbide. So you're getting of the acetylene gas. That is a acetylene gas. It is nothing but the artificial ripening of the fruit. These are about the 3 methods of the preparation. Now we go to the properties. In that also properties, I will also give the clue of properties. You can write easily of the properties one definitely, any one of you. Why? Because I want the alkynes. Alkyne is what is the formula? CnH2n minus 2. CnH2n minus 2 is called as alkynes. It is a general formula. When adding of hydrogen in presence of catalyst, nickel or platinum. Have you heard about this one? The first preparation of the properties, alkanes and alkenes. Alkynes is added to the hydrogen, means addition of hydrogen, or it is called as a hydrogenation. The process name is called as hydrogenation. Or it can call as addition of hydrogen. That means unsaturated hydrocarbons undergo addition reaction. But saturated compounds, hydrocarbons can undergo substitution reaction. Remember, this is the point also very important. Unsaturated hydrocarbons can undergo addition reactions only. Alkenes and alkynes can undergo addition reaction. Why they are undergoing addition reaction? Because the bond angle, that means the bond length is very close to each other. It is unsatisfied. So to remove the bond, that is a double bond or triple bond, getting of the freeness, they are undergoing of addition reactions like hydrogen and hydrogen halide, or you can say halogenation. Everything will be possible. But saturated hydrocarbon, it is satisfied. It is nothing to worry. It is freely sitting up so that they cannot undergoing any addition reaction. But under the drastic condition only, they can undergoing the substitution reaction. Under normal condition also, they do not undergoing of substitution. Under drastic condition, they can undergoing of substitution reaction. Here, this particular alkynes can undergoing of addition reaction. Just removing of, see, adding of hydrogen. What happened? You are getting of CnH2n. What is this general formula? Alkane. Again, this is hydrogenation in presence of nickel catalyst. What happened? CnH2n plus 2. What is the general formula? They are preparing alkane. If you want the preparation of alkanes, this is a step. This is enough. If you want the preparation of alkane, then this is a extended step. This is called as hydrogenation. This is a general method of preparation of the alkanes. Okay. So general method, you have to write that one. That is very important. This is a general method. That is called as addition of hydrogen, or you can call as a hydrogenation. Next is the general method, is the second, addition of halogens. Addition of halogen. What is now I am taking as a, this is the acetylene gas. Halogens means I am taking off the bromine in presence of ferric chloride. You can remember this reagent, very important here. Reagents are anywhere in a chemical steps. In the organic reactions, reagents are very important. Here, ferric chloride. Previously, dehydrohalogenation, you are using alcoholic potassium hydroxide. Dehydrohalogenation. But dehalogenation, you are using of zinc dust is the reagent. Here, addition of halogen, you are adding of the bromine. Easily does not take. Only under the presence of the ferric chloride. This ferric chloride is a reagent. This halogenation takes place and the formation of, see, I'm writing directly. Tell me the name, this one.
1,1, 2,2 bromo.
Tetrabromo. Tetrabromo ethane. Okay. Just whatever you are using the raw material in the preparation of alkynes, same you are using here. You are getting off with the halogenation. Addition of halogenation. There you are using the tetrabromo haloalkanes. You are treated with the zinc dust. You are getting off this one. Reverse order. But with the help of the zinc dust. But here you are with the help of the ferric chloride. You are using a preparation of 1, this is tetrahaloalkanes. You are preparing. This is the addition of halogens. Now third is very important chemical reaction is addition of water. They're simply taking off this addition of water, but here the reagents are very important. What is the reagent means? When ethylene gas is hydrolyzed in presence of sulfuric acid containing mercuric sulfate. These are the two are very important reagents. Compulsory question. It is asking for separate 5 marks bit. How the alkynes are hydrolyzed, what the product is obtained. So when the alkynes are hydrolyzed, that will be in the presence of sulfuric acid. This sulfuric acid contains mercury sulfate. So means the mercuric sulfate is dissolved in the sulfuric acid. It acts as a reagent. So that is dissolved in the water. Formation of, what do you get? Anybody knows this name of that compound? It is a very important.
Aldehyde.
RDS. What is this?
Acetaldehyde.
Okay. This is acetic acid. Okay. So it is nothing but acetaldehyde. It is nothing but acetaldehyde. Okay. This is a very important chemical reaction in the examination point of view. Sometimes not only the long question, there are separate a 5 marks bit addition of hydrogen or hydrolysis of alkynes. What happened? You will give that one. That will be here. Next is the oxidation. So when the alkynes or ethylene is undergoing of oxidation, you are getting off. This is also very important in your examination point of view. I'm writing off this particularly this manner. Do you agree? This is the alkyne. This is ethylene. Instead of in the linear form, I'm writing off in the this particularly in the particular column form. This particular ethylene. This is nothing but the ethylene. Ethylene is oxidized. Oxidized means what? In presence of nascent oxygen. So number of oxygen depending on the nascent oxygen means this is the O. So simple formation of. Anybody knows this formula? It is oxidized. Anyone? Very important. Very important formula.
Oxalic.
I will write the formula. H2C2O4. What is the name? H2C2O4. This formula, total formula is coming from journal. 2 hydrogens, 2 carbon atoms, 4 oxygen atoms. It is called as H2C2O4. It is called as oxalic acid. So when the ethylene molecule is oxidized in presence of nascent oxygen, for the formation of oxalic acid. This oxalic acid also further oxidized. For your understanding purpose only, I am writing. This is enough for your examination point of view. This oxalic acid further oxidized, you are getting off carbon dioxide plus water. Simply. Carbon dioxide plus water will be obtained. The last product. If you are oxalic acid, after the oxalic acid, you can't stop the reaction. Means you can furtherize that means oxidation. This will formation of carbon dioxide and water will be formed. Okay. These are about the important of the properties of your alkynes. See, in these 4 properties, I wrote the 4 properties. 2 are very important. This is a general method. This is a very general method only. Okay. So these 2 are very important. Now coming to the what are the uses of the ethylene? Every time asking. Ethylene, what is the use? It is used as a artificial ripening of the fruits. It is used as a for the cutting of the metals. It is used as a welding of the metals, and it is used as a in the particularly perfume and plastic industry, resins, formation of the resins, and plastic and rubber dyes. These are color properties in case. That means we can use for the ethylene is in the dyes, resins, rubber making, and the perfume making. This ethylene gas is used. So use is also very important. And in this particularly, the formation of the acetaldehyde as well as the oxalic acid. When the nascent oxygen is oxidized, this we are getting off this one. And one more question in this particularly this chapter consisting of why ethylene is acidic in nature than the ethane and ethene. See, the question is, I am again repeating, why ethylene is or alkynes are, I'm again repeating, why alkynes are more acidic than alkenes and alkanes. Guess and write. The question is asking in the examination. Are you followed my question? Again, I'm repeating, why alkynes are more acidic than alkenes and alkanes. Explain. Simple question. Now I will clarify that one. This is the topic is last in this unit. Why alkynes are more acidic than alkenes and alkanes. Explain. See, friends, here, remember, these are words. Pronunciation, if you are that is in here. So what is the sir means? I will explain. Please remember, this is the examination point of view. Very important. It is a repeated question. So what is that? First write the alkenes. First write the alkenes. Okay. Alkenes. Next alkynes. Let's discuss it now. Write the structural formula. This is ethane. Sorry. Very sorry. This is ethane. Double bond is present. This is ethene. Single bond is there. This is ethylene. So it is ethane. It is ethene. It is ethine. The common name is ethylene. The common name is ethylene. Is a common name. I'm putting the brackets. Okay. Now the first point I wrote the structural formula. Second point. Coming to the second point. The carbon-carbon single bond can undergo which hybridization? sp3 hybridization. Here the carbon undergo sp2 hybridization. It is undergoing of
sp
hybridization. Right. Now coming to the third point. I want this one. This third point is very important point. Now in the sp3, what is the percent of S character? In the sp3, what is the percent of S character? How can you remember, sir, that one? Anybody? Here, how many S are there? One spherical shaped S orbital, 3 dumbbell shaped p orbital mixing each other. Formation of 4 sp3 hybrid orbital is called as sp3 hybridization. I told in the first step. Okay, that means 1 plus 4 is equal to 100%. Sorry, 1 plus 3. 1 plus 3 is equal to 100%. That means 4 is equal, its total is 4. 1 is the S is the 1 is there. Means 1% is how much is? It is nothing but? It is nothing but 4 units is equal to 100%. 1 unit is nothing but 100 by 4 means 25%. 25%. Yes, character I am writing this is. Yes, character in the alkanes is 25%. What about in the alkenes? Yes, character?
50%.
1 plus 2, 3 is equal to 100%. Beta. 100 by 3. 100 by 3. 33.3%. Right? Now, what about this one? What is the S character in the SP?
50%.
50%. This is a 1 plus 1, 2 is equal to 100%. Means it is a 50%. Now coming to the my point here. Why the alkanes are more acidic than the alkenes and amines? See S character, what happened? In the alkanes, S character is 25%. In the alkenes, S character is 33.53%. In the alkynes, S character is 550%. That means gradual increasing of S character. Due to that reason, that is a S character is increases. This is the mobility of the 5 electrons will be very loose. That's why electrons are easily loses. This particularly alkanes are more acidic. So your reason is gradual increasing of S character in the alkynes. That's why acidic character will be more in the alkynes than the alkanes. That's you have to remember. Just show this picture. Just give the idea regarding of that one. Due to of the gradual increasing of S character from alkanes to alkenes. In the alkynes, S character is 50%. Hence, alkynes are more acidic than alkenes So, acidic character, if you are asking of anywhere in the multiple choice question, acidic characters from among the hydrocarbon means, acidic character is alkynes are more acidic than alkenes That you are to write. Okay, this is about the story of the unit 4. That is nothing but alkynes. In this, these are the important one only. So please remember that is the main important one. Next, fifth unit. Fifth unit is already 240. Our time is 230 only. 240. Just I will within few seconds I will conclude that one. Benzene is there. The fifth unit is benzene. What is a benzene? Main important. What is the formula of benzene? Why the formula is derived? Who derived the formula? What is the structure of the benzene? This is the 3 important points where we are discussing in the unit 5. So, what is the formula? How it is invented? What is the nature? What is the study? What is the previous history? You are discussing, not me. Okay. So, next is the structure of the benzene. The structure of benzene is very important. So, you are discussing in the benzene. So, benzene formula is already we know that C6H6. But how it is getting? What is the formula of that benzene? That will be derived. So, what is the nature actually? So, in the main important, the benzene we are discussing about why it is obtained. Actually, the first benzene is invented by, or you can say discovered by Faraday in 1825. In the 1825, Faraday is discovered by means of destructive distillation of whale oil. From the whale oil, he obtained the benzene. That is known as the benzene today. From the whale oil is discovered. So after that, after 1825, from the so many years, nobody knows that one. But in the 1834, Mitscherlich, one more scientist, proposed a name. Who proposed the name is Mitscherlich, not Faraday. Faraday is discovered the benzene, but he is not proposed the name. Mitscherlich is proposed the name in 1934 as a benzene, and also he derived the molecular formula is C6H6. Today you are using the benzene molecular formula is C6H6. Now this C6H6, if you see that one when compared to the hydrocarbons, CnH2n means C2H6, C2H4, C2H2. These are alkynes is C2H2. So C2H2 means alkyne. Similar manner, we are writing C6H6. It is a benzene. So while seeing of the formula, this benzene is also, you can understand that it is a very, very unsaturated hydrocarbon by observing of this one, the formulas. That means you are observing the general formula CnH2n plus 2, CnH2n, CnH2n minus 2, then CnH2n minus 6. This is the CnH2n minus 6, the general formula of benzene. So CnH2n minus 6 means it indicates it is a very, very unsaturated hydrocarbon. But unfortunately, this is a not a unsaturated hydrocarbon. So why I'm saying the unsaturated? So by seeing of that one, unsaturated hydrocarbons can undergo addition reactions. Saturated hydrocarbons can undergo substitution reactions. Or you are clear about that one from the alkenes to alkynes. I discussed every properties and preparations also. Alkanes can undergo a substitution reaction. Alkenes and alkynes can undergo addition reaction. This, if you are supposed to use it is a unsaturated hydrocarbon, it must undergo addition reaction. But benzene does not undergoing any addition reactions. It is undergoing substitution reactions. If it is undergoing a substitution means it is nothing but saturated. How? So that our scientists are very confusing about this one. This benzene is undergoing of substitution reaction instead of the addition reaction. It is called as aromatic hydrocarbon. So benzene is called as aromatic. What is aromatic hydrocarbon? Aromatic hydrocarbon is nothing but any compound reveals to unsaturated, but that particular compound does not undergoing addition reaction. It is undergoing the substitution reaction. Such compounds are called as aromatic hydrocarbon. Benzene is aromatic hydrocarbon. The Latin word aroma is a fragrant smell. The perfume is the aroma. Your biryani is aroma. The fragrant smell is coming. So that is an indication of this aromatic hydrocarbon is benzene and naphthalene, which is getting of this particular. So we will discuss the next class as the benzene structure and as well as the ethers. Okay. So today we conclude of that one. Any doubts? No more doubts, I think so. Only 13. Right, Amma. I'm leaving the class already 2:45.
Thank you, sir.
Thank you, sir.